Problem B2. That's about magnetism. Question 1. Magnetic moments. A model of the magnetic properties of materials is based upon small magnetic moments generated by each atom in the material. One source of this magnetic moment is the magnetic field generated by the electron in its orbit around the nucleus. For simplicity, we will assume that each atom consists of a single electron of charge -e and mass me. A single proton of charge +e and mass mp, and we assume that mp much larger than me, and that the electron orbits in a circular orbit of radius r about the proton. Assume the electron orbits in the xy plane. First, A. Calculate the net electrostatic force on the electron from the proton. Express your answer in terms of any of the following parameters done here, and the permittivity of free space epsilon 0. So this problem, it's very simple. It's just about electrostatic interaction between two charges, and we know that this force just equal to 1 over 4 pi epsilon 0, charge of 1 and other, which is e square over r square. So that will be answer for the first question. 1 over 4 pi epsilon 0 e square over r square. Question B. Determine the angular velocity omega 0 of the electron around the proton in terms of any or all of the following parameters. These all parameters. So if we have a charge radius r, we know that centripetal force will be F equal mass of electron multiplied by radius and multiplied by omega 0 square. So this is our equation. This centripetal force equal to force between two charges, and from here we can find that omega 0 equal square root from e square over 4 pi epsilon 0 mass of electron and the radius cube. So this is the answer for part B. E square over 4 pi epsilon 0 m electron r cube and the root. So this is the answer for second question. Question C. Derive an expression for the magnitude of the magnetic field BE due to the orbital motion of the electron at distance z much greater than radius of electron orbit. So if this is orbit of electron, this is z in this direction on distance z, and we count this vector as r, vector from instantaneous position of electron to our point where we measure this magnetic field. So we need to use so-called Biot-Savart law. It sounds like this. B magnetic field equal to mu0 current by contour over 4 pi, and here we have integral from d as cross product with r over r cube, and this integral by all this circuit. So what can we say here? We have some kind of symmetry. It means that if we made a cross ds, that's a small vector in the direction of this orbit. So it's like this. If we made a cross product this vector with a vector r, so we need to split it by two directions. One direction in z direction and other in plane xy. And it's obvious that in plane xy, due to symmetry, they just cancel each other, because this vector is just rotating. It has a direction perpendicular to our board and slightly up. So instead of this integral, we can write this expression mu0 I 4 pi. Here we can take 1 over r square out, and what is left? This direction in direction z. It means that we have a unit vector in direction z multiplied by ds, which is just a sine of this angle, and sine of this angle, that's r over r square I'm sorry, this is r square plus z square and root. So that's the expression, and we need to integrate it by circuit, which is just 2 pi r, and finally we have this answer. This will be mu0 over mu0 I over 2, and here we have r square over r square plus z square power 3 over 2. And because r is very small compared to z, so we have this expression mu 0 I over 2 r square over z cube. So this is our answer for magnetic field from one electron, mu0 over 2 multiplied by r square over z cube I, and I we just count from I just equal charge of electron divided by period, which is omega 0 divided by 2 pi. And omega 0 we already counted. That's this one. And finally, when we put this expression for current here, finally we will get this answer. And question D. A small bar magnet has a magnetic field far from the magnet given by formula B equal mu 0 over 2 pi m over z cube, where z it's same distance as in the previous, so it's a magnet on the axis connecting the north and the south poles. M is the magnetic dipole moment, and mu 0 is the permittivity, magnetic permittivity of free space. Assuming that an electron orbiting a proton acts like a small bar magnet, find the dipole moment m for an electron orbiting an atom in terms of any of following things. So we already counted what is magnetic field from electron is this one, and we just can equalize it to this expression mu 0 2 pi m z cube. And when we compare these two formulas, we see that magnetic momentum equal charge of electron multiplied by omega 0 r square over 2. So that's the answer for part D. M equal E omega 0 r square over 2.